All right, let's talk about this fun stuff. It's called 1 minus the probability of none. And I like to tell my students that this is any time you see the word at least 1. And it gets a little confusing because that at least, you don't know what to think. So I focus on what I call the none. It's not going to happen. So let's focus on it not happening. 1A, if a couple plans to have 3 children, what is the probability that they will have at least 1 girl? Well, we know that they want 3 children, right? So they want, you could either have a boy or a girl, or a boy or a girl, or a boy or a girl. So we have to think about them not ever having a girl. So we have to think about them having boys. They can have 1 out of 2 opportunity to have a boy, 1 out of 2 opportunity to have a boy, 1 out of 2, and this will be no success for a girl. So 1 minus the probability of none gives us 1 minus 1 over 8. Because 1 times 1 times 1 is 1, 2 times 2 times 2 is 8. And I love these because they're so easy, because I know my fractions, and you do too. So 1 minus 1/8 is just 7/8. Now, they're going to get a little different, so let's see what happens. What if the couple plans to have 5 children? What is the probability of them having at least 1 girl? At least being the key word, and we want girl. So again, 1 minus the probability of none, well, they can have boy, 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 hey, boy, and boy. And you should be familiar with 2 to the 5th power. So I know 1 minus 32 is 31 over 32. All right, let's get away from the children and let's just talk about random things. This is a good old statistics question. If you roll a die 5 times, what is the probability of getting at least 1 6? So we want all the numbers that won't be 6. Well, if I need 1 6, let's talk about a die just so I could draw this out for you. I can have 1, 2, 3, 4, 5, and 6, and we want 1 minus the probability of none. We want this not happening. So 1 minus, well, let's think about it. I know it's going to be 6 to the 5th power because we're rolling the die 5 times. And there are 6 opportunities in our sample space, meaning we could have 1 through 6. But we don't want that 6 to happen because we want 1 minus the probability of none. There are 5 opportunities of us not getting a 6. So yes, this is a totally obnoxious number. And it's 3,125 over 7,776. Now, yes, of course, you can use a calculator for this and hit math frac. So my answer is 4,651 over 7,776. Yeah, that's a little bit of a different answer. All right, let's talk about this. Number 3, a student experiences difficulties with malfunctioning alarm clocks. Instead of using 1 alarm clock, he uses 3. So we do need the keyword of 3 alarm clocks because we're going to have something to the 3rd power. What is the probability that at least one of his alarm clocks works correctly if an individual alarm clock has a 99% chance of working correctly? So we have a good chance of our alarm clock working, right? 99% chance of our alarm clock working. So now we have to think about 1 minus the probability of none. 1 minus, well, 99% chance that it works correctly. Guess what? I have 0.01 that it's not going to work correctly. And because I have 3 different alarm clocks, I have to put that to the 3rd power. So when I put this in my calculator, I get 0.999. I think this is repeating. So it says, what is the probability that at least one of his alarm clocks works correctly? It's 0.999999999. A little different of questions. All right, I'm going to move on to number 4, as this is probably our last one today, but this is also a great one. In a lab, there are 8 technicians, so I probably need this number 8 somewhere. 3 are male. 5 are female. Ooh, let me color code them so we know. 3 are male, 5 are female, and we know that 3 technicians are selected. Find the probability that at least 1 is a female. So once again, I need my pen. 1 minus the probability of none. So if I want at least 1 female for all my nones, I want them all to be male. 1 minus, well, how many technicians do I need? I know I need 8. 3 are male, so if I want all males to be picked, because that's what I want on my none, 1 minus the probability of none, I want 3 over 8. Well, now we're down to 7 because only 7 technicians are left. But again, I want it to be a male because I want 1 minus the probability of none. So I want 2. And then I have 6 technicians left, but there's only 1 more male left. So this is the probability that all are male. That's what it means by 1 minus the probability of none. We don't want this female to ever happen in this little parenthesis right here. So when I calculate that, I get 1 over 3 times 2 is 6. You know what? I'm going to go ahead and reduce here because I know that these 3 and 2 reduces with 6. So I just get 1 over 56. I like to make my life a little easier. So the probability is 55 over 56.